Hi, everyone. My name is Houssam Hamad. I'm a senior solutions architect at AWS. I mainly work in the energy vertical. I specialize in renewable energies. And from a skills perspective, my background is in big data analytics, AI, and machine learning. So I really help customers figure out, that digital transformation journey, how to build digital twin of their industrial assets in the field, whether it is, an oil and gas rig in the Gulf of Mexico, or a wind farm in Florida that Nextera might manage, right? Today our talk is really to introduce you to what are the different stages of achieving, your asset visibility, then moving on to detecting anomalies, then moving on to predictive maintenance, and then moving on to prescriptive maintenance. And we'll talk about the challenges that customers have going through that journey and these different stages, and how we can help you achieve, asset visibility, predictive and prescriptive maintenance with our AWS services. Also, just want to thank you all for your time today. We really appreciate that you come, show up, and listen to us talk here. I want to also thank all of our partners here in the room. We really appreciate our partners. Our partners are a great resource to accelerate your journeys. AWS is a lot of building blocks. Some of these partners have already built the solution for you. So take a look at the marketplace and see if you can find these pre-built solutions instead of investing multi-million-dollar projects. So what are digital twins? It's a live digital representation of a physical system or asset that is dynamically updated to mimic the structure, state, and behavior of your physical system to drive business. What we're trying to do with digital twins is really look at, condition-based maintenance versus when you have, a list of specs of a wind turbine, for example, and it tells you that you need to maintain this wind turbine every 6 months. You need to send a crew to go and maintain this turbine. You're doing this blindly. You're going there. Maybe that turbine does not need maintenance. Maybe it's perfectly fine. Maybe because of the weather pattern and the winds have not been aggressive in the last months, this wind turbine barely operated, thus reducing the wear and tear on the equipment, right? So when we want to move into a condition-based predictive and prescriptive maintenance, we really focus on, what are the industrial problems we're trying to solve, and how can we minimize downtime? This is the biggest business outcome for most of our industrial customers, is minimizing downtime of their asset and optimizing asset utilization. If we look at the promise of digital twins across all industries, basically, whether it's manufacturing, small buildings, power and utility, and energy, it's really business transformation through Internet of Things, artificial intelligence, machine learning, and overall the cloud technologies that are offered by AWS. The business outcomes, really, we try to streamline the operation, optimize your resources, and anticipate issues before they arrive, not to create downtime, to maximize that asset utilization as much as you can use it. But building digital twins is pretty hard. There's no silver bullet that solves this equation. There's a lot of data that's coming from disparate sources. It could be from sensors on your industrial equipment. Some equipment doesn't even have sensors. So now you need to add sensors to collect that data. Modeling the asset over their lifetime. So you really want to be able to have a deep understanding of the lifespan and life cycle of your assets in general. And to be able to drill it down to the individual asset and being able to compare this asset with the other ones that you have that are similar in nature, and try to understand their lifetime, life cycle, maintenance criteria, and so on. And again, done with data that you're getting directly from the asset, not by the spec book that the manufacturer has given you to say you need to do this at this date, you need to do this after this much utilization. It's really monitoring a whole fleet of, let's say, wind turbines, right? And detecting what's not normal, right? You can, by looking at your whole wind farm in one location, same wind patterns and so on, you can detect if one of your wind turbines is not acting normally compared to the others through that life cycle. And then creating effective visualization. This is things done in Power BI, let's say from Microsoft, or Tableau, or our own product, QuickSight, that gives you these visuals. I'll be doing a very quick demo at the end to show you what that could potentially look like. So journey to data-driven operation. The first phase is always reactive. Our customers start with just gaining visibility to the asset. This phase is really about ingesting the data from the assets in the field, and also all of the data that resides in other systems, like, let's say, your asset management system, your customer relation management system, your ERP for financials around these assets. So like we said in the previous slide, all of this data is completely siloed in most cases. Now you need to bring this together to, first of all, gain that visibility into the asset, understand how it's functioning at the moment. Then we want to go into the phase 2 is preventative, where you can schedule maintenance activities according to what you're noticing from those monitoring dashboards that you're putting in place. Getting that telemetry data from the field, combining it with vendor data, and then being able to schedule the maintenance depending on where your work crew is, where are the parts, right? How fast can you get those parts from your vendors? And then being able to schedule those maintenances in time by all these variables and factors. Finally, the phase 3 and 4 is predictive and prescriptive. This is when you start using machine learning and AI to predict a failure before it happens. Maybe you're running at a hotter temperature, and that correlates to a RPM that is really, really high on your wind turbine. There's been really violent winds, and this is by friction, it's creating this really high temperature in the wind turbine, thus reducing the lifespan of that equipment because you're running at a hotter temperature, right? What machine learning is going to be able to do is, by looking at all your historical data, your asset data, and the telemetry data that's coming in, and also doing the comparative analysis with the other assets that you have, let's say in that wind farm, it's going to be able to tell you, listen, we think that there's an issue with this asset. Here are the readings that are detected as anomalies. And in phase 4, here's a very prescriptive procedure on how to fix this issue. So you can imagine, I built a demo with a customer once where it was basically called Well Buddy, right? And it was for oil and gas operators to go in the morning. They would just through a chatbot interact with Well Buddy, and they would say, "Hey, Well Buddy, what are the rigs I have to see today?" And then the Well Buddy comes back and says, "Okay, rig A, B, and C." And then you can go, "Hey, Well Buddy, what is the problem with rig A?" And then Well Buddy come back in the chat and says, "Well, we detected the high temperature, we detected high pressure, and so on. Okay, can you give me the telemetry data reading?" And then it sends you the graph of that reading. And then, how do I fix this issue? And then it can direct you to a YouTube video that shows the operator how to potentially fix this issue. So all of that can be integrated when you're able to bring that data together, but nobody starts here. Let's just make that clear. Everybody will start here. First step is to gain visibility to your assets in the field, and being able to monitor in near real time those measures that are coming from that telemetry data. So what are the challenges here? Limited visibility into the asset performance. Operational data can be trapped in those silos. We talked about it a little bit earlier. It becomes really hard to move that data around when you have different data types, when you have different protocols of communication, and so on. What AWS has done is we bring a collection of services to help you do these things, and we'll get a little deeper into how we solve these challenges. The second one is firefighting versus strategic improvement. So when you're doing the firefighting, it's always higher cost. You're not minimizing the downtime of your asset. You're basically doing break and fix. So you wait for the asset to break, and then you go fix it. Unfortunately, when you leverage this methodology, it creates downtime of your assets, and it costs a lot of money to companies. For example, if we take an oil and gas use case, drilling. So drilling completion is the most expensive part of getting the oil out of the ground, right? Any day of delay, right, downtime because of the equipment, because of the drill bit, because of whatever is in there that's breaking, costs millions and millions and millions of dollars to operators. So they need the ability to make sure that they can minimize that downtime by getting the insight from their data. When is this asset potentially going to fail? And how can I minimize that outage or completely prevent it? And then graying workforce and knowledge gap. So, you've got some operators, very senior ones, 30 years in the business, they know what they're doing. They can look at the graph and immediately say, the problem here is vibration. And there's structural vibration coming out because we're running this too high RPM. The materials around this, let's say compressor, the metal here is capturing the vibration and it's communicating all that back to the equipment and it's degrading the equipment, right? But when you have newer staff, they don't have that experience. So really, it's to bridge that gap for these less skilled, less experienced people by bringing that data to their fingertips and being able to give them, through machine learning, prescriptive ways to solve, the issue that is at hand. And we train these models really based on the more experienced people. So, we get like data scientists and then industry people together, and then we look at these measures. We build the machine learning behind it, the models, the algorithms we use based on the trade expertise, based on, let's say, a drilling engineer will sit down with us, will explain to us what he looks for, what's normal, what's not normal, and then we code that. All right, solving challenge 1, increasing visibility into asset performance. So you want to remotely monitor your assets. You want this to be done in near real time with inside dashboards of your asset performance. You're going to asset modeling and hierarchy structuring within that. So you're going to look at the top asset, then you can define other assets that are either components of that asset or connected to that asset as well. Liberating the data from the disparate systems and devices. I'm not going to get too deep into the technology aspect of it here, but at a high level, you can get your data directly from the sensors. Some organizations already have what we call historians, like OSI Pi, that they're already collecting that telemetry data here. This piece here is edge computing. This enables you to be able to run some machine learning at the edge without being connected to the cloud, running your dashboards locally as well. So what you can do is you can train your machine learning in the cloud, and then you can push that at the edge with something we call AWS Greengrass. And then what happens is a lot of these sites can be, in places where there's limited network connectivity. So now you can actually run your dashboarding and all that from the site, leveraging, what we call the green grass with maybe a WebSocket and then a web application that shows that monitoring dashboard, right? And then you can build your models in the cloud for anomaly detection, deploy them here. Really what we're trying to help with on the edge side is when network communication is very limited or it cuts off and comes back, even for the data, when you send it to the cloud, this enables you to aggregate that data here until network comes back and then send it back. So interconnectivity, the edge piece, and then really what we're trying to derive here is near real-time insight, near real-time operational KPIs through dashboarding and so on. 2, enabling strategic improvement process through data-driven methodology. So you want to identify the asset issue before the failure of that asset. You want to try to improve the performance of the equipment over the lifetime. So some manufacturer will tell you, don't run my equipment more than 500 RPM, right? Don't run it more than that. But that's just in general. They try to cover a 70-30% kind of thing to say to their customers, this is what we've noticed in general that is running optimal. However, what we've discovered is when we've switched to condition-based monitoring and we integrate a lot of factors such as weather, such as other equipments interfering with the asset that you're looking at, all of that together will give you a better idea of that specific equipment, in that specific environment, when is it going to fail, versus just the documentation that says, you can't run this more than 500 RPM. Maybe you can run it at 1,000 in the conditions that you are. It all depends on how your equipment is installed, where is it installed, and so on. Finally, provide near real-time data-driven insight to key stakeholders and systems. So you want to integrate insight into utility, operational, and business systems. You want to, when you're getting your data and then running machine learning to do anomaly detection, once anomaly is detected, this needs to be fed back to something, to a system, to an application where an operator could get that and then react to it. improve workforce effectiveness by enhancing purpose-built applications. So when you have the ability to leverage our big data services and AI machine learning services, you can improve workforce management. For example, I have a wind turbine, 2 wind turbines that are failing in the field, right? One is located, let's say, in Ohio, the other one is in Florida. My workforce is right now closer to Florida. The power output of the one in Ohio is higher. The power output in one in Florida is lower. However, the work crew is closer to there. I got the parts in my inventory versus the other one I have to order it from the manufacturer. So now you can make better decisions on which one to fix first. If I fix this one, is that going to restore power faster to my power generation, or is it the other one? And you can only gain that by cross-correlating all that data together and then feed it back to a visual interface where people can take action. And what you want to do also is future-proof the utility workforce. So as we're gaining more intelligence, as we're gaining more prescriptive methods to solve issues with the industrial assets, these things become really repeatable in nature. And then we can have all of these procedures documented. So and leveraged by machine learning, where it can link the issue that you have with the prescriptive guidance to remediate that issue. This is where you can get more junior people involved faster and really accelerating their learning curve. So how do we make this happen? This is the future and new kind of industry pattern that we're seeing. It's called the data mesh. So it's really to enable your organization from a business perspective to own their own data. So finance owns their data, HR owns their data, operations owns their data. And then all of these distributed, decentralized data lakes interconnect together with what we call AWS Lake Formation that helps you to govern the access to all of that data within these distributed data lakes. Why do you want to do a distributed data lake? Number one, scale. So when you're starting to scale up, if you have one centralized data lake, not from a technology perspective, but from a people and process perspective, you're going to hit a roadblock. If you have one team that does everything data, and it's like your centralized data platform team, they're going to become a bottleneck sooner or later. As you're increasing the data footprint, as you're increasing your use cases to do predictive, preventive maintenance, as you're increasing the use of machine learning and data science, these teams are going to start becoming a bottleneck. So the first thing you want to do is decentralize the access to the business units. So they have now what they do is they have these senior data analysts who are data stewards into these different data lakes, these different business units, and they're in charge to give access to the other department. There's nobody better than a finance senior person to understand the compliance and who needs to access that data. IT cannot say that. IT will send a service request to the finance person and say, can I give access to that piece of data to this other person? Where you streamline that process is you put that data steward inside the business unit and they handle these requests and then share the data out to the people that need that data to do their job, basically. So when you look at it, once we get to the full picture here, you get, this one is more on the bank side, but consumer banking, corporate technologies, corporate investments, they all have their own data lakes. They all have their own data domains that they host, and they share that data with each other into this mesh. And now the complicated slide. I'm not going to spend too much time on this. The only thing I want to explain here at a high level is really you got 3 layers when you're doing advanced analytics and machine learning. You've got a data ingestion layer where we have many services that can help you render different use cases. Depending on if the data ingestion is asynchronous or if it needs to be done in near real time and so on, you're going to use different services to do these things. Also, depending on where your data sources are. For example, if it's coming from devices or wind turbines, in the field, it's going to go through most probably IoT Core, because this is a service that's purpose-built to ingest telemetry data and send it to a good storage location for that data. If you're doing near real time and you need to do analytics on the fly, on the data stream, to detect anomalies really, really quickly, you might use something like Kinesis Analytics. This is Amazon Kinesis. There's 3 versions: Firehose, Analytics, and the regular stream. But Kinesis Analytics, you can put SQL in it, and then it will, when the data comes into the stream, it will run that SQL and detect what you need, what your query is trying to detect. Now, when we move to the right, there's the storage layer, then we're going to store the data. And now the most important part that makes the data lake happen is the data catalog. So AWS Glue is basically a Hive metastore and big data in Hadoop. And then what it does is it has these crawlers that will crawl the data that you put in here and discover the data schema automatically. Once that data schema is discovered, now you can query that data in your data lake once you have a schema. So data ingestion, storage cataloging, and data transformation, right? You can use ETL jobs here to transform your data and so on. And then access channels, which can be accessed by machine learning, by an enterprise data warehouse, directly from a BI tool, and so on. All right, and with that, I'm going to switch to a just really, really quick demo just to show you guys, you know, how this actually can look like. Oh. I have to reconnect to my workspace. While this is connecting, any questions that I could answer? All right, so if I go here, all right, so this here is a IoT Device Simulator. Basically what it does is it enables us to run some proof of concepts and stuff like that with our customers. It simulates a device in the field. So you can think of it as an oil and gas compressor or wind turbine. And basically it generates a JSON payload that has the telemetry data in it: temperature, pressure, crankshaft angles, stuff like that. So this is emitting data continuously. And if we take a look at one here, you can see the payload here that is generating. And this is sent through an IoT MQTT topic. So it leverages MQTT protocol to send that data to the cloud. If your industrial equipment does not talk MQTT, don't worry about it. We have a translation layer. If you're running OPC UA, Modbus, OCPP for the charging points for EVs, we have this conversion layer that we can put on Greengrass to be able to convert it to MQTT. So now we can see that we're producing the data. Now let's go see how are we ingesting that data. So if I go to IoT Core, and then I'm going to go and test my topic. So it's compressor data. Is it S or no S? I think it's S. Yes, so we can see the data that was emitted by the sensor, right, into the simulator now is coming into IoT Core. Once it's inside the IoT Core, this is going to be leveraged as an orchestration. You can do a lot more with IoT Core. I'm not going to spend a lot of time with this. This is like we could do like a week of training on IoT Core. But yeah, just simply put it, you're ingesting the data and then you want to act on that data. So you're going to write a rule. And this rule here, basically, it's a very simple one. It says, capture the data from the MQTT topic and send it to Amazon time stream. Also, I have a Lambda function that's doing a minor data transformation to put it in a good format to absorb into that time series database. Time stream is, equivalent in the market of InfluxDB, OpenTSDB. I wouldn't say OSI Pi because they have more functionality than just the time series database. But yeah, any popular time series database in the market is comparable to time stream. So once we write this, if now this data is being written to the database, the time series database time stream, now we can start visualizing this data. So if I go to Amazon QuickSight, and this could be Power BI, it could be Tableau, it could be Grafana. There's a lot of BI visualization tools that you can use. And our technologies obviously are open source, so you can use whatever tool to visualize this that you're comfortable with. So if we look here, but one really good feature of QuickSight, and I've seen it in Grafana as well, I don't know if Power BI has it. They might, but I'm not sure. So you can see here, it's loading the data. All right. So this is in UTC time. So 3:59, it is 11:59 Eastern. So you can see how fast I'm getting the data, right? From those sensors, right? So whether that's wind turbine in the field or whatever, you could expect as aggressive of sync on the data from a continuous data perspective. Now I'm joining this data in this dashboard. This top part is live data that's coming in from the sensors. And this bottom part is data that's coming from our asset management system, from our customer relation, from our vendor management systems. And now, like I said earlier, that use case about identifying where your workforce should go. Now, I can see here, you see this here? This is machine learning. This is anomaly detection. And at AWS, we're trying to democratize the skill that is required to do machine learning. So you don't need an expensive team of data scientists to build this stuff. So within QuickSight, we've already bundled models for anomaly detection, for forecasting, for drift on values. So we've already put that in here. Now, what's really interesting about this is that it's actual machine learning and you can train the model. Very simply, if I look at this anomaly right here, it's going to tell me that the average value forecasted to be blah, blah, blah. Oh, this is a forecast. And then when I get that forecasting, I can say to the machine, was this good or was this bad? And as you're telling it, it's a good insight or it's a bad insight, it's learning. It's becoming smarter and smarter and smarter. And you do this without a single line of code. This is what's fantastic here. You can do this also in Grafana. We do have AWS managed Grafana that looks like this. Grafana is actually better for telemetry data. It's purpose-built better for that kind of telemetry data. But yeah, and then if I look at here, okay, I detected this, I have an anomaly, I have a forecasted here. I can look at, let me go here and see. So if we go into this one here, now what we could do is we could add an anomaly sheet here, and then you can get more granular with this. So it will pop up what you can see as results. And then you see detected here an anomaly, right? And then we can start playing with the parameters on how I'm detecting those anomalies, right? It could be based on a value, it could be based on averages, it could be based on many things. Finally, the whole point of this is really to get you all of the data together to be able to analyze this. And if we go look at my data sets here, oh, that's not the right one. Yeah. So you see here, I have that compressor data, telemetry data. I could add data here, and then I can go here and a data set, and this is in my data lake. These things are in my data lake. So I can bring this one here. I could go select. And then I can configure, and let's say a full join, and then by device ID, and in my other data set, it's a case ID that it's called. So it could be different columns, but as long as the values in those columns are the same, you can correlate that data together. So I go apply. Shouldn't take too long. There we go. And now I got both data sets that are integrated together, and I can visualize that data. Now, if I go back to my dashboard, what does that, whoops, to my analysis here, what does that actually mean? Just cancel this. That means now that I can get a unified visual between anomaly detection, where are my vendors and components location, where's my wind farm, who are my manufacturers, what parts do they carry, and then the description of that specific turbine. You can see here the capacity that it produces, 3 kilowatts hour, so and so on. And this will help you make better decisions, and preventively manage your assets so you don't generate downtime. Any questions? I know it's a lot of information, and don't be afraid of all of this stuff that I showed. AWS SAs are here to help you through this journey. We are a free service to our customers. So whenever you open up an AWS account, you'll have an account team with an account manager and a senior solutions architect that's going to help you through your journey. And it's a free service. We give training. We do demos with you guys. We can prototype something for you to show you how you could build it yourself. And again, we have like the difference I find in my career with AWS is that I've always been a sales engineer, but there's no sales in Amazon. I don't have quota that I have to reach. I have nothing like that. On the contrary, if I go in and I reduce your bill month over month and I optimize the way you're using AWS, that's how I get promoted. So it's a very different way of working with our customers. Now, yeah, I'll say it again after the sustainability chat, but at the end of the day, when I get back home, I'll send you guys a CSAT survey. We really appreciate your feedback. This is how we can make these sessions even more interesting to you. As Amazonian, we're extremely customer obsessed, and your feedback is extremely important to us. Thank you all.